Alright, I welcome you guys, and today we'll be going more in depth into the separation of variables. Okay, and we're just going to be working with it. So if you remember from when we talked about the beginning of Diff EQs, growth and decay, we talked a little bit about separable equations. Today we'll definitely be working a lot with them. So let's start working with them. Let's do an exact example. So dy dx is equal to x divided by y, something simple, and y equals 2 when x equals 1. Okay? Alright, so we set it up. Now if you notice, the y is right over here, so we'll be multiplying both sides by it. Okay, so we got y dy equals x dx. Okay, now I'm going to antiderivative both sides, or find the antiderivative. Okay, I like to just call it integrate, you know. Okay, so let me see. That is going to be y squared divided by 2 plus c. And this is going to be x squared divided by 2 plus c as well. Okay, now if I put the two c's together, it's just going to get a different c. So this is going to just be y squared over 2 equals x squared divided by 2. Okay, nope, I have the plus c there, because it's not going to change, it's just going to stay the same. Now I'm going to plug in y equals 2 and x equals 1 to find c. And so this is going to be 4 divided by 2 is equal to 1 divided by 2 plus c. So I'm going minus 1/2 from both sides, so 3/2 is equal to c in this case. Okay, this is helpful for finding the constant. So I'm going to go back to right here, and I'm going to redo this part. Let's go red. Okay, so I get y squared divided by 2 equals x squared divided by 2 plus 3/2. Okay, so we've done this. What we're going to do now is solve for y. Okay, so we're going to, if you notice over here, they both have a common denominator, so y squared. Well, if I multiply everything by 2, I should get y squared equals x squared plus 3. Okay, and if you notice, all I have to do is square root it, and I'm all set. So y is going to be equal to the plus or minus version of the square root of x squared plus 3. Voila! I have my formula that I differentiated down to get x over y. So some really cool stuff that you're able to do. Or y equals the plus or minus the square root of this. Okay. Alright. Let's do some more practice. Okay, so let's do something like dy dx equals 2xy. And y equals 3 when x equals 0. Okay. Alright, so we start working with this. So if you notice, we're going to have 1 over 2y, which we can just change to 2y. Well, I'm just going to have the 2 here, and I'm going to space it out a little bit. 2y to the negative 1 dy, and you'll understand why in a sec when I'm setting this up. I could put the 2 on the other side with the x. Yeah, I probably should. Let's move it over there to the x. Let's put it over here with the x. So 2 space x dx. Okay. Alright. Was not thinking clearly on that one. Okay, so we're going to integrate right here, and as you can see, I'm keeping 2 out as a constant. Okay, so this is going to be the natural log of the absolute value of y. Okay, and it's going to be equal to 2, well, it's just going to be x squared plus c, because if you know, the 2 and the 2 that comes up when I integrate are going to cancel out. Okay, now what I'm going to do first is find c, so I'm going to plug in my stuff. So the natural log of 3 is going to equal 0, okay, plus c, so c is equal to the natural log of 3, so that's pretty simple. Okay, so I go back to here and I replace it. So the natural log of the absolute value of y, and some of you guys are probably asking, like, do I really need that? Yes, you do. Okay, so plus the natural log of 3. Okay, now in order to get rid of this and to make this a nice easy thing, guess what you have to do? You have to exponentiate everything, so raise it to the e power. Raise that to the e power. Okay, so I bring that down, and that's going to be the absolute value of y is equal to, now I'm going to break this apart by using my exponential rules. So this is going to be ex squared, so I'm going to bring that 2 in front, so that's going to be 2 times e to the x, and then plus e to the natural log of 3. If you remember your rules, this just becomes 3 because these two cancel out, so this just becomes 3. Okay. Alright, and that is pretty much it on that one. So that means that we can actually just get rid of these right here, and we would have this as plus or minus. And voila! We actually have everything all said and done. Y is alone. We found it with understanding. Now, whenever you have the absolute value of y left, you just do plus or minus on the other side, because that could be a positive or a negative value right there. Okay? All right. And so it's this nice, neat little package that we just worked out, and that is it. All right. Let's practice some more. Okay. All right. So we're going to do a little bit more of a difficult one right here. dy dx. Okay, let me get back to my thing of cosine squared of x, or cosine squared of y, and y equals 0 when x equals 0, which makes sense. Okay, so I do everything, I work everything out, and this should be 1 over cosine squared of y dy equals 1. I'm going to put the 1 here. Now it's technically not there, but it's going to be 1 times dx. Okay, so I'm going to integrate both sides. Okay, now before I do that, you need to recognize that this is a nice little reciprocal identity. So this turns into secant squared y dy equals 1 times dx. Okay, so I'm going to integrate both sides. So let's draw our little integrate sign. Okay. And this is going to be nice and neat because this is going to be the tangent of y equals x plus c. Okay. Now what I'm going to do is I'm going to plug in the zeros and everything. So tangent of 0 equals 0 plus c. Okay, and if you remember, tangent of 0, I'm just double checking, it's definitely going to be 0. So 0 equals c. Okay, so when I go back to here, tangent of y equals x. Okay, pretty simple. I'm going to do the inverse to both sides, so y equals arctan of x. Okay. Oh, let's put the equal sign in there because that would make it nice and neat. And voila, you have done separable integration of this function up here. Okay. All right. There's a ton of other examples. If you see trig, try to use trig identities to break it down. But just remember what the process is that you're just separating into functions of y and x, and then you're integrating each side. And make sure you find c. Always find c when doing this stuff. Okay. All right. That is it for today. I will talk to you guys later. Bye.